Yeah, so I asked the class to tell me their opinion, what you think a server is. I know you already have an idea what a server is, but I would like to know from your personal observation, can you tell me what is like the difference between this PC and a server? It's more faster because it has higher processor. Okay, that's good. What else? What is the major difference between a server and the PC that we use now? So this is a good point. Actually, a server is not different from the PC that we use, except the fact that because it handles a lot of users, so it requires higher capacity in terms of the speed, the processing power, okay, and the number of requests that it can handle. This is the most important thing. But aside from that, the components of a normal computer are almost the same with the components of a server. Okay? Server is dedicated for a specific purpose. It can be a server that is designed for a database, okay, or for a website. You can have a DHCP server, you can have a DNS server. These are specific for a specific purpose. The reason is because they are meant to provide a certain service to the users. And the users are probably going to be of high volume. So basically, you're going to have a lot of users. And therefore, you will need high capacity of the machine to handle these requests. So this is the basic idea of a server. So servers are the foundation of all service platforms. If you remember, in the first chapter, we said that cloud computing provides three basic services, right? It can be infrastructure as a service. What's the second one? First one, infrastructure as a service. Second one is what? Platform as a service. Excellent. SaaS, that's software as a service. Okay? So that is to say that cloud computing technology is designed to provide services to users. Okay? And the users are gonna be of high volume also, because cloud computing technology provides these services to users all over the world. So therefore, there is going to be a lot of users. For that reason, we need a machine that can handle high volume of requests, right? So therefore, we need a server. Okay? But the basic idea is any platform that provides services will require a server. Okay? Any platform that provides services will require a server. Cloud computing provides infrastructure, platform, and software as a service. So these are services provided to who? To the users. Okay? Therefore, we need, therefore we will need a server for that purpose. Let me use yes. So any platform that requires services will need to have a server. So that's the idea. The objectives of this chapter are, we are going to look at the roles and features of a server. Okay? Server technology, the roles and features. We are also going to look at the different types of servers, the hardware components of a server. If you have a server right now, what are the different components? And then the key technologies of a server. So in the first section, we will introduce server as we just did, and then we will define the full meaning of a server. And then we look at the server development history, server types, and server hardwares. In the second section, we will discuss more about key server technologies that are used. So let's take the first section and go through it together. A server, by definition, is actually a computer. That's just what we mentioned, right? A server is a type of computer. So that's why I was asking at the beginning, what is the difference between a server and the normal PC that we have? What is the difference? They are actually both computers. But in terms of the processing capacity, okay, it's faster, it carries more loads, okay, and it costs more if you go to the market to buy, because of course it has higher capacity, therefore it will have most likely to be more expensive. A server provides services to the users. That is why any platform that provides services to users will require a server. But there are different types of servers. There are servers that are file-based servers that handle files, database servers, and application servers. If you remember, in one of the classes, I mentioned that previously, when I was still in my bachelor's program, we used to design a website and we will need a server to host the website. Therefore, we use our computers to operate the computer as a server. But then you have to keep the computer running 24 hours, uninterrupted power supply. You need steady internet supply also, and you will need number of requests to be of high volume. I mean, the capacity of the system should be a very good system. But then maybe you will see the computer is very small and the capacity is very small. So even the website, if somebody is trying to access it, you will write the URL and then you press enter and then it will be going. Maybe you will go to the new building and come back, still it's trying to load a single website. It takes a long time to load, basically. Why? Because we are not using the type of servers that we use now. And we use normal PCs to make them to be like a servers to provide these services. But then this is not the best way. Okay? So in the case where you have a server, servers provide for you reliability. If you have a server, it is more reliable. Okay? Because you don't think much about crashes. Maybe the system will crash because it's designed to handle this situation. So no matter the volume of users trying to access the site, it will not crash. It will simply schedule them and basically give them the availability to access. So that's why we say it's also available. Okay, it's reliable, it's available, and it's scalable. It's scalable, we explained in the previous class. You can increase or decrease the components or the service that you need. And it's easy to manage, so it's manageability. And in terms of user friendliness, it's quite easy to use and configure, basically. It's more or less similar to a device that we have. Okay. So server application scenarios. What are the scenarios that we need to think about buying a server or having a server? At what point do we need a server? So these are the scenarios that you need a server. Number one, if you have high volume of files that you deal with, you may need a server. If you have large database like the student registration in the college, you need a database. Then you need a server, database server. Okay. If you have email is basically the email server that we use. The email server and the email server and web server in a normal topology, they are located in which aspect basically? The DMZ, right? Because this is a bachelor's class, so you've taught, you've learned this before. Email servers and web servers are located at the DMZ, demilitarized zone. Okay. Then we have application servers, like the website I mentioned. It's an application server. Okay. DNS is a server that. What's the function of a DNS server? Who can tell me? Okay, how about DHCP server? It's not mentioned here, but we have DHCP server. Who remember what it is? Your networking class. Then we have the proxy server. DHCP is the one that assigns for you IP address automatically when you connect to the internet. DNS assign names basically. So these are two different stuff, Server development history, how it started. Okay, I don't like much of history. Okay, but it started with a mainframe and mid-range computers, like the computer I told you I used to use. It's a small computer, it's a mid-range computer. Then it moves to microcomputers like this type. Okay, this type is a microcomputer. Then it moves to x86 servers. Let me show you a picture of it. It looked like this. Okay, these are the servers. Okay, so this is the x86 servers, and then it moves to cloud computing. So basically, from a mainframe or a mid-range computers, small computers, to microcomputers, to x86 servers, and then to cloud computing. Now, cloud services, we don't basically need a normal physical server. We just simply use the cloud server. So this is the development of, or the history of servers. It started from cloud 1.0, cloud 2.0, and now we are in 3.0. If you remember in the first chapter, cloud 1.0 is it has some applications that we mentioned, like the Zen application. 2.0, it has VMware, one of the applications, and 3.0, it has what? 3.0, it has the containers, yes, containers applications, okay, or Dockers and containers. 3.0, we mentioned this in the previous slides, chapter 1. All this information are there. Okay, server types, the different types of servers that we have. These are the different types of servers that we have. Hardware servers, these are hardware servers. Okay, this is the mainframe. Okay, it looked like this. Mid-range computers look like this. The tower server is the type we have in our new building. Okay, and the blade server. So these are new types. And then the rack server. The rack server is more or less like a small horizontal or flat type of server. So in terms of service scale, if we have to categorize the servers in terms of their service, that's what we call the entry level. This is the small one, okay? The work group server, the one that you can use in a simple place that have like not more than 50 users, okay? If you have clients that are not more than 50 users, you can use the work group. But if you have like 100 users, okay, then you can have departmental level server. But if you have more than 100, hundreds of thousands of users, then you need enterprise server. It handles more users than all the remaining categories. Server hardware. The hardware of a server is classified into different components. Now, the interesting thing is that the components of a server and a component of a computer are not actually so different. We mentioned this at the beginning, except the fact that they are actually faster and has more capacity and cost more. Okay? So in a normal computer that we use, we have the CPU, right? We have the memory, we have the drive, which we call the hard disk, and we have the rate controller, okay, and we have the NIC, and then we have also the power unit, which is also called PSU, power support unit, and the fan. The fan is the one that in the normal CPU, you will see the fan at the back side. It will be raw. Yeah, it simply try to give ventilation and cool the CPU, because the CPU mostly it gets heated because of a lot of activity. So the fan simply try to give some kind of cooling to it. Okay, so these are the different components of a server, but let's discuss them one after the other. Pictorially, this number one is the case, okay? Is the case. Number two is the motherboard. This is the motherboard, okay? Number three is the memory, where you plug in the memory or you remove it, which we also call the RAM, right? The RAM or the ROM. And number four is the CPU. That's the processing unit, basically, or processor. Then the CPU heat sink, because it emits a lot of heat. So they have like a space where this type of heat just goes out like that. Then the power unit, PSU, power supply unit, PSU. That's number six. Okay. Then the fan, number seven. This is the fan. It gives the air and then it moves out um, through the outside, okay, which is called the air duct. Air duct is number nine, where the air goes in and out. Then we have the drive, that's the hard disk. Number eight, this is the hard disk. So these are the different units. If you have access, you can connect and check on the Huawei's website. They have an animated video that shows and explain more about this diagram. The fan and the what? 7 and 9. Oh, the fan is the one that rotates. The air duct is the um, it's like the airways where the air will go out and It's not a fan by itself, but just like a perpetrated something like this, okay, where air goes in and out. So this is it basically. Just a space given where for the air to goes in and out. A window for the air to goes in and out. Okay. CPU is the next component. Do we have a CPU in a computer? Yes. Do we have a CPU in the server? Yes. So that's why we say the components are the same. Okay. So let's look at what a CPU is. The full meaning, of course, is central processing unit. Now you need to start remembering your, is it computing fundamentals or something? Yeah. So you need to remember computing fundamentals. The CPU contains the register, the ALU, and the controller. Okay, so I will just simply explain them one after the other. The register. The register simply take records of instructions coming in and out of the CPU. Okay, as the name goes, it's just simply a register. It takes records of history, okay, of activities, of instructions, because the CPU process instructions. Okay, so the instructions moving in and out of the CPU are recorded by the register. Then the ALU, arithmetic logic unit. Who can tell me what it means? Let me say what's the function of. Very good. So the ALU, from the name, arithmetic logic unit, it does two important tasks. One is the arithmetic operations like addition, subtraction, multiplication, and division. Okay, or taking a percentage. Okay, all these are arithmetic operations. They are being handled by the arithmetic unit. Okay, but then there's a logic unit. What is logic? Then you remember your logic gates, right? OR gates, AND gates, XOR gates. So all these are handled by the logic unit. So that's why it's called arithmetic logic unit. Okay? But then there are decisions also. These decisions are logic, like a decision symbol in arithmetic, sorry, in flowcharting, where you have the diamond shape and you have a yes or no, right? Yes. So any decision will be either a yes or a no. So all this is also handled by the logic unit because that's a logic basically. Okay, so logic unit. Arithmetic unit, it handles um, something like plus, minus, multiplication, and division. Okay, the logic unit, you have AND, O, X, and all stuff like that. Then we have the controller. The controller, basically, from the name, it controls instructions and interprets them. Okay, so the controller, it controls instructions coming into the CPU and assign them to the CPU accordingly. So you can see that we have input device, right? And we have an output device. The input device send the instructions to the CPU, okay? The CPU register it and process it according to the ALU, and then the controller controls the instructions by either sending the instruction to the input device, to the output device, or storing it in the hard drive. Okay, so it controls the instructions that moves in and out of the CPU. So these are the main and most important components of the CPU that you can find in a server. These functions are exactly the same like what we have on a normal PC. additional information. That's what we call CPU frequency. And CPU frequency is divided into different types of frequencies. The first one is called dominant frequency. Okay, this is dominant frequency. Dominant frequency is also called the clock speed because it measures the speed which the CPU actually compute instructions or process data. Okay, the input device sends the data to the CPU. How long it takes for the CPU to complete the instruction processing or to process the data that is being sent by the input device and send this output to the output device. How long it takes. Okay, so basically it checks the time. That's why it's called clock speed. Okay, time of what? Time of processing or time of computing an instruction. That is what is called dominant frequency. So let's look at the second one, external frequency. External frequency is the reference frequency of a CPU, also measured in megahertz. Now, this is something I forgot to mention. The dominant frequency, the unit is what? Megahertz or gigahertz, okay? The unit of the speed measuring this thing. For dominant frequency is measured in megahertz or gigahertz. But then also for external frequency is measured in megahertz. Okay? And this one, it only measures the frequency, okay, or the speed of the motherboard. Okay, only the motherboard, the motherboard speed. If you remember, let's take some steps backward. We mentioned that the second one is the motherboard, this one. Okay, this is the motherboard. So the speed of the motherboard is called the external frequency. Then we have the bus. The motherboard is also a component of a server or a PC that basically contains and manages the CPU, the RAM, and the ROM. So we have bus frequency. A bus frequency directly affects the speed of data exchange between the CPU and what is called dual inline memory module. So basically is the speed of data exchange between the CPU and another component called DIMM. DIMM is dual inline memory module. Basically, it has to do with the memory also. So the speed of data exchange, if the CPU sends an instruction to the DIMM, how long it takes to arrive there. And if the DIMM sends instruction to the CPU, how long it takes to arrive at the CPU. So the exchange of data, what is the speed between these two components? This is called bus speed. Last but not the least, we have what is called multiplication factor. A multiplication factor is the ratio between the dominant frequency and the external frequency. Okay, now just remember that the dominant frequency is the first one. The external frequency is the second one. The ratio between the two is called multiplication factor. Now, let's look at it logically. When we say a ratio, mathematically, what is the meaning? A ratio. From 1 to 5, no.
Something to divide it to
Exactly. Okay, so now I want to give you a formula. When we say a ratio is division, okay, simply, anytime you see the word ratio, something is dividing something. Okay, they are telling us that we have to divide the dominant frequency divide by the external frequency for us to get the multiplication factor. That's what they are telling us, okay? So multiplication factor, MF, sorry, I don't have mouse, so it's very slow, is equals to dominant frequency divide by, because they say the ratio of, okay, external frequency. External frequency. This is the formula. But there's something confusing here. Maybe you didn't notice at this point. But maybe if you go back home and start reading, it will occur to you that, oh, they say multiplicative factor. But now they are doing a division. Do you understand? The name is multiplicative. That means that it's supposed to be a multiplication, you know? But then they say it's a ratio of, they are doing a division. Why? Don't worry. Multiplication and division can always find a way to exchange each other. So this formula is also equally the same thing as df dominant factor, dominant frequency multiplied by E external frequency rest power 1 minus, sorry, rest power minus 1. It's the same thing actually. So now it means that our multiplication finally we found it. That's why they call it multiplicative basically. So for example, if we say that the speed of processing an instruction by the CPU is 100 megahertz. This is what? This is what, from all what he explained here. It means it's 100 megahertz is the dominant frequency. Sorry? Now, the speed that it takes the CPU to process an instruction is what? No, it's the dominant frequency, okay? Okay, so if we say, for example, if we say it takes 100 megahertz of frequency for the CPU to process a data, it means we are given simply 100 megahertz to the speed of the CPU. Then we say it again, it takes 50 megahertz, okay, for the motherboard to complete an instruction. So now we are talking about the external frequency, right? So then I will ask you, calculate the multiplicative factor. What do you do?
For the second example,
Yes.
no, I will not
So
divide because in another word, I cannot divide it.
you just simply divide, no problem. So the DF, which is the dominant factor, 100 megahertz, divide by 50 equals to what? 2, right? To give you 2. But is it going to be 2 megahertz, 2 gigahertz, or what? It's simply going to be 2 because this megahertz will also cancel this megahertz because we are dividing here. So it will just be 2 only. So 100 megahertz divided by 50 megahertz is 2. So that means the multiplicative factor is 2. This is just an example. Okay? Maybe a question can come out in this way. The memory. Let's discuss the memory. The CPU does all the work of processing. But sometimes the CPU need to keep the instructions somewhere, either permanently or temporarily. You remember this? So once the CPU keeps the instruction in a temporary position, it keeps it in a RAM, random access memory. And this is a volatile type of memory. Okay? But when it keeps the instruction permanently, it goes to the hard disk, the ROM, or the hard disk, or you simply say the drive or the storage device, basically. Right? So in this case, if you off or shut down the computer, the information or instruction kept by the CPU in a temporary position, you cannot recover it back when you boot the system again. Okay? But if the instruction has been saved into the hard disk, of course you recover it. That is why sometimes if you type in a Microsoft Word and suddenly you have not saved yet, the system goes off. If you boot back again the system, you cannot get some information that you already typed because you have not actually saved. You didn't send it to a permanent location. It is still in a temporary location being processed by the CPU at the time. Okay, so this is the idea of a memory. So let's look at how it works in a server. Is it the same idea or is it different? Well, actually it's the same. So this is how a memory, this is a RAM actually. There will be some slots you can add a RAM. I remember basically before we used like 100 gig RAM, and then your system will easily get filled up, and then maybe you go to the market and buy, go to the mall and buy another RAM, and then you slot it in. So maybe you have 100 before, now you add another 50, it becomes 150, or it goes like this. This is how we play around with memory before, RAM. So a memory is of course a storage, okay? It's a storage. A storage is classified by purpose into main memory or external storage. Main memory is also referred to as internal storage. That is basically the hard disk, internal storage, okay? The storage space that the CPU can address Of course, the CPU can locate information on the hard disk based on some addresses that's been assigned to it. Okay. In forensic, you remember we have the hex. I don't know how many of you took forensic. Ah, okay, okay. But at least I know how many. Aljazi, now you took also before, yeah. So you remember the hex? If you do the scanning with maybe OSF, it gives you the addresses of the location of the information on the hard disk. Okay, so actually this is the addresses that the CPU is using to locate information on the hard disk. So memory is also a memory is used to temporarily store CPU operations. So I told you before, the CPU sometimes keep information temporarily in a memory, in a RAM, because maybe it will use it later, immediately. So it keeps in a RAM. But you need to save it. If you didn't save it, it will not go to the hard drive. Okay, for it to go to the hard drive, you need to save. If you save, the data will move from the temporary location from the RAM to the hard drive. And in that case, if the computer goes off, you can simply come back and still get your information. So one important component of the CPU, yeah, is the memory. The memory consists of memory chip. Yeah, these are the three components that makes a memory. Memory chip, circuit card, and edge connector. All of them are shown here. Okay, this is the memory chip. Okay, this is the circuit card. Okay, and this is the connector. I don't know how if you can see it. The edge connector. Okay, so you simply take it and connect it to circuit card, and then it works. How about the drive? The drive is the hard disk. And we have different types of hard disk: the SATA hard disk, the SSD, and stuff like this. Okay, yeah. I've been the one talking. I want to hear something from the class. Can you identify a hard disk if you see a one? Can you identify hard disk? Do I have one here or I remove it? I don't know. Yes, I have one here. This external hard disk, right? You can use it just like USB port. You can connect it and then you can use it. So this is a SATA hard disk actually. This one is SATA. Because this is a casing, but there's a place they normally write a SATA hard disk. So you can connect and you can save it just like where you save stuff in the USB port, in the USB flash drive, basically. So I will not waste much time here. SATA hard disk is only one of this type of hard disk. Okay, there's also SAS hard disk, there's NLS SAS, and the SSD. SSD also is very popular. Okay, and I think if you are looking for speed, okay, maybe SSD is the right one. But if you are looking for storage space, then you need a SATA hard disk. Okay, you can see you can have like 1 tera, 2 tera, 3 tera. Actually, this slide, I don't believe this slide is up to date because now we have 9 tera. You can have 9 tera SATA hard disk. Yes, if you go to market, you can find. Okay, but in terms of the SSD, you can see the highest one is 1.6 tera. So in terms of capacity, you may need like SATA hard disk. Okay, the the SAS and the NL SAS are actually using the same technology. Okay, except that they try to add additional functions, okay, to the normal one to increase its capacity. So you can see that like the SAS here is 0.9 tera, but now you can have NL SAS to have up to 4 tera. Okay, so in terms of the number of instructions that it can actually handle, you can see this is 1.2 million, this 1.6 million, this 1.2 million, this 2 million instructions. This shows like the differences. Okay, yeah. So at the end of the day, the most important point I will mention here is that all of them are serial port users. They are all serial port users because actually there are some disks that we used to use before that are parallel port users. Okay, so hard disk can be a parallel or a serial, but now most of the technology they prefer to use serial because it's faster, is it takes more space and stuff like that. So let's go to RAID controllers. What is a RAID?
Something as redundancy more than just.
Exactly. RAID. Your name again? Nora. What is a RAID? A RAID. This one. You know? Not yet. They are taking forensic now. So we are not yet there in forensic. You still have to teach. I still have to teach this in forensic. If you are taking forensic now, you need to learn it now so that if we go to chapter, I think chapter 6 in forensic, you will have an idea what it is already.
Grade 6, grade 6.
Yes, there are different types of rates, okay? From rate 0, rate 1, rate 2, up to 15, 16, like this. Different types of rates, okay? So RAID, as she mentioned, is hard disks that are designed for redundancy. Redundancy simply means if an information is lost in one hard disk, you can find it in another one. But it's designed in such a way that you have multiple hard disks, but if you put them in a RAID controller, it will start working like a one hard disk. Do you understand? You have multiple hard disks. If you put them on a RAID controller, it will start functioning as single hard disk. That's why it's called a RAID, okay? So this is a RAID controller, okay? On it, you can see there are many slots here. So you can arrange multiple hard disks on it, okay? And then these multiple hard disks, they can start working as a single hard disk. So basically the RAID controller is the controller that takes in the hard disk. You can connect all the hard disks in it. The benefit we just mentioned, redundancy. She mentioned it. Okay? Because if you have a RAID device, maybe one of the hard disks got crashed, the information in it is lost, right? But in a RAID device, because of redundancy, you can find the same information in another device within the RAID. Okay? So this is the general idea. But of course, we have different types of RAID. RAID 0 did not follow this principle. Okay? But if you go to RAID 1, then redundancy starts from the and it's like this. Okay? So this is an example of, yeah, so logically this is how it looks like. You have multiple hard drives. This is one hard disk, like the hard disk I just showed you. You have one hard disk, two hard disks, all connected, but now they are working as a single unit. Okay, single unit. So that's why it's called redundant array of independent disk. It improves issues of redundancy, okay, and improves performance. Performance improvement, basically. So in terms of how it connected, we show you the controller. Now, how do you connect it? Okay, in a server. In a server, the controller bus is here. Okay, you have it here, and you can connect all the RAID devices. Okay, this is the controller box. The controller box basically helps send information to the CPU and receive information to from the CPU. Okay, so you can have your RAID controller card here. It helps to send information and receive information to the CPU. Everything, if you look at this, everything is in one single box. This is called hardware RAID Mod 1. This is the Mod 1. The Mod 1, it uses built-in plug-in cards. But we have another one called Mod 2. Mod 2, it uses external independent drive arrays. In this case, the RAIDs are in a different box, while the CPU is another box. Okay, then you have the SCIS box that connect them. Okay, the RAID controller can still send information to the CPU through the SCIS card. Then the CPU receive the information and execute it, and then send it back in the case of trying to save the information in a RAID device. So this is how it works. Two types of connection or implementation of RAID are the Mod 1 and the Mod 2. Now the thing is, in case if you have learned about RAID 1 and RAID 2 and RAID 0, then you see Mod 1 and Mod 2, they are not the same. Mod 1 and Mod 2 is only talking about the connection of the RAID to the CPU. How you can connect the RAID to the CPU. In Mod 1, you can simply use a RAID controller card in between the CPU and the RAID to connect them. In Mod 2, the RAID and the controller card are in the same box. The CPU is in another box. Okay, then you use the SCIS cable to connect them. Sorry?
Same as the picture?
Similar to the picture. Okay, so this shows the connection of the RAID and the CPU. That's what it's showing for Mod 1 and Mod 2. Say RAID 1 and RAID 2 is referring to the connection of how you arrange the redundancy hard disk. We will still discuss this, I think, in the next chapter in this course. Okay, we will discuss RAID 0, RAID 1, RAID 2, just like we did in forensic. There you can realize that somehow the courses sometimes they interwoven. Then we have implementation in terms of the software. Sometimes you simply use a software to connect the CPU and the RAID devices. And all you need to do is to have the RAID software to install it. Once you install it, the RAID software can control the connection. Okay, so this is easy. What you need to do for this, since it's using a software, is simply installation of the software. Once you install the software can help you to control the RAID devices and be sending information to it to the CPU. Okay, so basically you don't have to do a lot of work. The CPU can still perform at optimal level. Okay, and it reduces a lot of cost for you. because it's simply a software. So you can see this is the connection for the software. Okay, this is the one we discussed as mode 1, built in. This is the one for mode 2. Okay, external RAID. So these are the advantages of each one. So if you are using software, the advantage is that low implementation cost and is flexible configuration, because you only need to install the software and the software takes over from there to do the remaining things for you. However, if you are using built-in RAIDs, that's mode 1. Okay, the advantage are it provides data protection and high speed, okay, and better fault tolerance. What is fault tolerance? Fault tolerance. It means that if there's a fault, it can still continue to work. Okay? And it's also cost effective, it's not so expensive. Support for bootable arrays, it has. But if you are using the mode 2, this mode 1, well, this mode 2. So if you are using mode 2, these are the advantages. Okay, configures dual controller to improve data throughput and stuff like this. Okay, and of course it's very scalable. In terms of scalability, it's very scalable and it supports hot swapping. Let's go to Nick. We're almost finished with these slides.
We have 10 slides.
Really?
10 on this.
Yeah, but the remaining slides are very shallow. They are not very detailed.
10 slides.
It's good. We can finish before 3 o'clock.
Yeah.
In the next 15 minutes, I believe we can finish. Nick. What is a Nick? What is it used for?
It's a part of computer network system.
Yes.
It's give the network access, access to the connection.
Yes. That's very good, actually. A NIC is network interface card. Let me tell you another story. Before, if you buy a computer, you only buy a computer only. If you want to connect to the internet, you still need to go back to the shop and buy a NIC. Then you come back and open the CPU, not the CPU, the system unit, and plug in the NIC. And then you go to the BIOS and start the NIC, enable it. And then that's when your computer can connect to the internet. Do you know that this exists? No, because the manufacturers realize that what is the use of making the users always going back to the market to buy the NIC? And the manufacturers are always trying to make life easy for us. So now, from the manufacturing company, they design the computer with the NIC together. So if you buy your computer, you simply boot it on and you will see the network will be on. How it comes off is none of your business. What is making the network to work and have an internet connection is none of our business. Our children will probably never know how a NIC look like. Why? Because in the time they come into the world, the NIC is actually done from the manufacturers, everything, and it simply comes in, and all they need is just a gadget. And then they start browsing. But actually, without a NIC, it simply means that you cannot have internet connection. You must have a NIC for it to work. I remember before, sometimes if like the internet is not going and you'll be wondering what happened, then sometimes you need to open the system unit and remove the link and plug it again. Maybe it's not, you know, maybe it's not fitted well, you know. So you need to remove it and put it back, and then you boot back the system, and then it comes up again. So this is how it works. So this is how it look like. Okay. By definition, network interface card. It simply provides computer network system with access to the network. Network access. The functions of NIC: fixed network address, data sending and receiving, data encapsulation and decapsulation, link management, encoding and decoding. These are the functions. But if we have to look at it according to the layers, okay, at the data link, sorry, at the application layer, it simply works with data, okay? At the transport layer, it works with TCP headers and data. At the network layer, it works with data, TCP headers, and IP addresses. At the data link layer, it works with MAC headers, MAC address headers, IP addresses, TCP, and data. So these are the things. Of course, at the physical layer, this is where it sends and receives the data that needs to go to the network, okay, or received from the network. So this is how the NICs work. And these are the functions of the NIC. Huawei, they try to advertise for us their own different NICs that they have. Okay, so they have their own NICs that they use in their server. Know it. Just know it. I wish I can delay slides like this. They have a NIC called lump card. Okay, the lump card basically is embedded in the server motherboard and cannot be replaced. Okay, so they do it in a way that it cannot be replaced. Just like what I said now, the manufacturers, they make sure that the NIC comes with it. So in a lump card, you cannot replace the NIC. It comes with it. Just remember this, it cannot be replaced. The lump card. PCIe card is another type of NIC also. They can be installed in standard PCIe slots, these ones. Then the Flex input output card or Flex IO card also is developed by Huawei, which can only be used in Huawei rack server. You know, we have different types of servers, and the biggest one or the last one is called the rack servers. So this Flex OI is used in rack servers. Mezzanine card is another one. Okay, the mezzanine card are only used in the computer nodes of Huawei Blade servers. So they use it in Blade servers. The last section, PSU and Fan mode. You know what we are still trying to explain? The different components of a server, right? Now we are going to the last part, which is PSU is what? according to the first diagram of server that we showed. Power support unit is the power where you get the electricity to go in and out of the server, basically, right? And of course, the fan mode. The fan mode is the fan that regulates ventilation and cool the CPU we mentioned. So let's look at how it looks like. This is the power system, PSU. Power, it supplies power to the server. Yeah, the PSU supplies power to the server, and it's very good in terms of fault warning and prevention, pre-fault preventive maintenance, non-destructive server device services. Okay, and we have what is called intelligent server unit as part of its components, and the fan mode. Fan mode is basically, this is the fan mode. Okay, you can see that this is like the airspace where the ventilation of heat moves in and out of the server unit. So the last part, key server technologies, we have the BMC and the BIOS. The BMC, before we go to the BMC, there's what is called IPMI. IPMI is Intelligent Platform Management Interface. Basically, this communicates with the BMC. BMC is baseboard management controller. The baseboard management controller is also a component of the server that works with the motherboard. So the IPMI and the BMC works together embedded in the motherboard to basically control instructions. So anything that has to do with exchange of information, okay, is simply done by IPMI and the BMC. BMC helps to manage all these instructions that moves from the client, that's your PC, okay, to the server. So this another function, definition, I mean, BMC compiles the IPMI specifications, okay, it compiles it. What it does with it, it collects, process, store sensor signals, and also it monitors components of operating status. Okay, so these are the main functions. It collects, process, store sensor signals, and also it monitors components of operating status. So this is basically the function of the BMC. And the Huawei, they introduced what is called IBMC, an intelligent version, basically trying to add AI to it. Okay, so it's called Intelligent Baseboard Management Controller, IBMC. IBMC is embedded in the server management system, and it performs 4 different functions. The first one is it monitors status, which is called status monitoring. It does for you fault diagnosis, and also it runs records on the server. And then last but not the least, it diagnoses assistance, basically, to check any failure related to power, serial port, last screenshot, last video saved, and stuff like this. So this is the function of the IBMC. Then the BIOS. The BIOS is basically basic input-output system. That's a BIOS, okay? Basic input-output system. What is it used for in a computer? What is the function of a BIOS? Yes, it manages instructions coming from the keyboard to the CPU, okay? Like keyboard is what? An input device. Also mouse, yes, it manages information from the mouse going to the hard drive or the operating system through the kernel, okay, and then run applications. But I always try to give this example. If you off your system or shut down your system for 1 year, if you come back after 1 year, you boot your system back, you'll find out that it will show the current date. It will show the day of the day you boot it. I mean, not the day you shut it down. Why is it so? If we shut down all the systems here today and we went on vacation, after 2 months we came back, we boot the systems again. Which day is it going to show on the system? The day of today. But the system is not on. It was unplugged. It was shut down for 1 month. How come the date is showing today's date? How comes? It is because of the BIOS. The BIOS works with the BIOS works with what is called a CMOS. A CMOS is also in the system unit. It's a battery. The battery can keep the time for many years. The CMOS. Okay? Yeah, so that's the end of the slides. Let's try the first question. Which of the following statements are true about the NICs of Huawei servers? Now we remember that Huawei servers have different NICs. The LOM, the Flex IO, and stuff like this. You remember them? So which of this is true? It says the LOM is embedded into the PCH chip on the server motherboard and cannot be replaced. You remember I told you it cannot be replaced? Is it true? Is it true? This is true. Huawei developed PCIe card can be installed in standard PCIe slots. The Flex OI card is integrated with the server panel for front-end service connection. Is it true? Mex9 cards. Sorry? Is it? It's not rack? It's what? Rack servers, there's one that is used for rack servers, there's one that's used for. It's correct, right? So all are correct. So all of the above is correct. This multiple answer question. Let's go to true or false. BMC, what's BMC? Baseboard management controller, right? Compiles the IMP specifications. It collects, processes, stores sensors, signals, and it monitors components. I think I remembered I put this the same way here. It collects, process, store sensor signals, and monitor component operating status. So this is true. Everything is true.